The science of glazing damage assessment is something that it really is a specialty, because there are so many different types of window systems. There are so many different types of fenestration products out there. For the majority, you know, we have the condominiums type, which is kind of like what you see here. In Texas, you got the thin nail window. Down where we're from in Florida, there's a lot of flange type stuff, and I'm going to kind of go over some stuff. Also, we're going to show some really interesting slides to help you guys pinpoint certain key elements to look at when we're talking about damage and causation. Because, and I say this to a lot of people that I talk to, a window is not just a piece of glass. And the insurance companies would have you believe that, and how many of you guys have heard this? You'll probably raise your hand. If that glass was broken, we would have paid for it. Right? You know, you've heard that time and time again. Hey, well, the glass works, or what do? They go up to the window and they open it and they close it and say, hey, it works. Like, it works, you know? And then what happens is a lot of times, because the knowledge isn't there, the case gets wangled around and nobody pursues it. Well, there is science behind windows. There is direct evidence to show causation and damage. And this is where we work as a team. My company, we do specialty glazing assessments of all different types of structures, from curtain walls to commercial stuff to residentials to shacks at the beach. It doesn't matter. They all have unique characteristics. And it's our sincere hope to bring a little bit of education to your community. So when you're in a structure, your eyes are open when you're looking at a piece of a window system. Because there's another statement that we have, and that is, people look through windows, they don't look at windows. And I want you guys to start thinking about looking at windows. A window is a complex component. When I landed, I went to Home Depot because I didn't have a sample small enough to bring in my suitcase. And you know, I thought I'd bring one on board, and basically every seat that you have in an airplane is a window seat if you have your own window. But, but you know, I went to Home Depot and I came over here and I picked up this sample. It's probably the cheapest window they have. This is called a nailing fin, because out here in Texas you got your wood frame, a lot of wood frame stuff. Where I'm from, it's a little bit different. When you put this thing in, you're going to prep your opening. There's a lot of waterproofing that goes in. The AMA Society, the American Architectural Manufacturers Association, they have all kinds of codes when it comes to weatherproofing a structure when you install a window. There's a code which is the 2400-02 code, which talks about how you properly insulate a fenestration opening from the elements. Well, there's all kinds of stuff, and especially down here when you're applying this thing, the opening has to be prepped properly. They screw through this nailing fin when they place the window on the structure, and then they put weatherproofing material over it and caulk the openings and kind of create a weatherproof seal. Now, what you got here in Texas is really interesting, because this fin type window actually becomes a part of the structure, nailed directly parallel into the structure, which means when it damages, there's no existent screw field. Okay, when you walk up to that window, you're not going to see screws all over the place. It just doesn't happen. The screws and the nailing fin is a part of the system. It's covered up, it's hidden. So what attacks these windows in Texas is negative and positive pressure. And I had a great thing, but we just couldn't get it to fire up. Have you guys ever seen a cyclical wind pressure test? You never did? You have, right? It's cool, right? Go online, go to YouTube, type in cyclical wind pressure test. Yeah, on YouTube. They got one out there as a vinyl window, and I wish we could have got it to work, but we're not compatible here. It is unbelievable, and I really want you guys to understand that these products have a certain testing protocol that they go through. They're designed to withstand a certain amount of load, of wind speed, of wind pressure, and basically in construction we've got a unique situation, and that is the state of Texas, because I'm in Texas now, the state of Texas allows you to make these big openings in your structure, and then they say, oh, put something into it. Well, we want to have view, the architect say, let's put a window. You got your concrete, which exists at a certain design pressure. You got this big gaping hole in your building, and then you fill it with something, which is a window. This window is a system that's designed to equalize design pressures from one side of the masonry to the other side of the masonry. So that building, when it's acted upon after that static load leaves and it becomes dynamic load, that building doesn't crumble from the inside. So these windows are built in a certain way to withstand pressure, wind speed, and in new cases, impact, okay? And water, moisture infiltration, water infiltration. That cyclical pressure test, which you're going to go check out, shows the actual testing protocol in Miami-Dade. This is a Miami-Dade window, which is really one of the most stringent. I probably second next to Australia, because we had a hurricane that came through, Hurricane Andrew. It rewrote the books on everything after Hurricane Andrew. These windows, when you see that, they basically install a window. They impact it with an air cannon, with a 2x4, 9-foot long 2x4, and they slam it at different sections of the window. I'm going to lean this up on this table if you don't mind. No, it's okay. I got it right here. Thank you. Couple of things. This is your integral fin, which you're not going to see. Okay, this is a horizontal roller window, which shows that it opens horizontally, like that. If we turn it on its side, it's going to become like a single hung window, which you're going to see, in a lot of different environments. In a single hung window, where the operating part of the sash, which is right here, meets the sill panel, is called a meeting rail. Okay, this section here is called a meeting rail. The window system takes stress along the frame, so much so that the stress point on the glass bead right here is where you're going to see a lot of damage. We look at this slide over here. Okay, now I showed you what a meeting rail was. This is a single hung window of a high-rise that we looked at. What I want you guys to write down and think about is something called cascading damage profile. Write that down, because when you're talking to the insurance guys, you're going to throw that at them. That there is a cascading damage profile on this system. And it's going to be important, because if you walk up to a window, you see a little cracking on the drywall, it doesn't mean that there's a lot of damage to that window. It just means that you might have had some type of carpenter who was lazy and didn't finish the drywall and didn't reveal it properly. Here, you've got, you see this frame bending here? Can you see that? You see that bowing of that meeting rail? That bowing of that meeting rail is a substantial thing to note. That window was put under such amount of, this is called negative pressure. What happened was the wind, when it came through that building, wrapped around the building, came to the opposite side, created suction. By creating suction, this part of the operational sash was pulled outward, which warped this part of the meeting rail as that glass gave way. A couple of things happened. This glass gave way here. The light gasket, which is that seal right here that's seating this piece of glass, was bending along with this and dislodged. Okay? So we have this light gasket unset. We've got this frame bending right here, and the whole operational sash shifted, and it is not going back into the rail, into the operational rail. This is cascading damage profile. Multiple points of damage that point to this window being acted upon by intense positive and negative cyclical pressure. You see how that works? Okay. So when you're looking at a window, I want you to take a far view of a window. Kind of step back and look at it. Okay? Don't just look at the glass like the insurance company wants you to look at, because if a pigeon didn't fly into the thing, and if you're up, higher than 3 stories, because in construction, the first 3 stories is what's called the large missile impact zone. The next 3 stories is called a small missile impact zone, and everything above that is a different scenario altogether when you're talking about building a structure. Well, nothing impacted this window. You didn't see any major glass breakage. You didn't see any major disruption from impact. But what you do see is cyclical pressure testing. Window damage is hidden. It's not something that you're going to just, most people are going to walk by it and not even give it a second thought. That's why we're here to open everybody's eyes to say, hey, there's something more than just a broken piece of glass here. You understand? Okay, let's go to the next one. This is a different situation altogether. This is an architectural window system.